Hello everyone, welcome back to Advent of Code. Today we're going to be working on day 6. I don't know anything about this day, although I did hear a rumor from one person that it was easier than yesterday, which sure would be nice. I could use a break. Yesterday I kind of slogged through. Day 6, wait for it. The ferry quickly brings you across Island. After asking around, you discover that there is indeed normally a large pile of sand somewhere near here, but you don't see anything besides lots of water and the small island where the ferry has docked. Didn't one of these places need water? There's a big pile of water here. Okay. As you try to figure out what to do next, you notice a poster on a wall over the ferry dock. Boat races, open to the public. Grand prize is an all expenses paid trip to Desert Island. That must be where the sand comes from. Best of all, the boat races are starting in just a few minutes. You manage to sign up as a competitor in the boat races just in time. Man, this guy really lives on the edge of his seat, huh? If only I were so spontaneous in real life. The organizer explains it's not really a traditional race. Instead, you'll get a fixed amount of time during which your boat has to travel as far as it can, and you win if your boat goes the farthest. As part of signing up, you get a sheet of paper, your puzzle input, that lists the time allowed for each race, and also the best distance ever recorded in that race. To guarantee you win the grand prize, you need to make sure you go further in each race than the current record holder. It's very ambitious. The organizer brings you over to the area where the boat races are held. The boats are much smaller than you expected. They're actually toy boats, each with a big button on top. Holding down the button charges the boat, and releasing the button allows the boat to move. Boats move faster if their button was held longer, but time spent holding the button counts against the total race time. You can only hold the button at the start of the race, and boats don't move until the button is released. Counts against the total race time? The time for, that one boat, or for all the boats? Do they all happen at the same time? I don't quite understand. Okay, well, here we go. The first race lasts for 7 milliseconds, and the record distance is 9 millimeters. The second race lasts 15 milliseconds, the record distance is 40 millimeters. The third race lasts 30 milliseconds, the record distance is 200 millimeters. Okay, your toy boat has a starting speed of 0 millimeters per millisecond. Yes. For each whole second you spend at the beginning of the race holding down the button, the boat's speed increases by 1 millimeter per millisecond. So, because the first race lasts 7 milliseconds, you only have a few options. Don't push the button. The boat won't go anywhere. Hold the button for 1 millisecond at the start, and then the boat will travel at 1 millimeter per second for the entire time. Yep, makes sense. Hold the button for 2 milliseconds, 2 millimeters per second for 5, it goes 10. Yeah, okay. Sure. Anybody, it's symmetrical here. Is that a coincidence? That it's symmetrical around the center? I don't think it is, right? Because this is a parabola. The total distance should be modeled by a parabola, right? I think, well, I think there's some point in the middle of the race, which is about half the time, that it's optimal to hold the button down for. And on either side of that, you can, let's say the race was 6 seconds long. Or, well, how long is this one? 7. Yeah, right, 3.5 would be exactly the center. Hold it down for 3.5 of the race. That's in between these two 12s. If you could do 3.5, you would get slightly more distance, right? You can't, because it's a discrete thing. But it would have a speed of 3.5, and it would travel for 3.5, which would be 3.5 squared, which is, I don't know, 3.5 times 3 would be 10.5, plus half of 1.5 is certainly more than 1.5, right? It's 1.75, so you gotta be slightly further. So I think this describes a parabola where the center is the best, and then at either end, if the center is not an integer, then either end of the center is the best. Like, suppose we had, instead of 7 seconds, we had a 4, right? Then half of 4 would be 2 seconds, and I argue that would be the best amount of time to hold it for. It would travel for 2 seconds at a speed of 2, getting 4 distance. Or you could travel for 1 second at a speed of 3, or for 3 seconds at a speed of 1, either end of the parabola, right? They're sloping downwards from there. Okay, since the current record for this race, okay, it is listed, is 9 millimeters, there are actually 4 different ways you could win. 2, 3, 4, or 5, yeah. In the second race, okay, so... To see how much margin of error you have, determine the number of ways you can beat the record in each race. In this example, if you multiply these values together, you get a number like so-and-so. Okay. So... I feel like you shouldn't solve this one in simulation, right? You should just do a little tiny bit of algebra, maybe some calculus. All right, I took a little break here. I had a brief coughing fit, which I think you caught just the beginning of, and then I took advantage of already having cut the video to go do some math off camera, so I didn't have to do that on camera and think about what algebra is needed to solve this. And here's what I ended up writing. And I think I haven't written any Haskell yet, but I've done some math here. Because we have some variable we want to solve for, like how long we need to hold down the thing to beat their speed, right? So I just wrote down an equation describing an example race. Suppose we had a race of length k seconds, and we were to hold the button down for s of those seconds, traveling us a distance of d. Now, our opponents aren't actually doing this. If you look back at the problem statement, in 7 seconds they went 9, a distance of 9. That's not possible using the mechanism that we have, right? Is it? Right, you could hold the thing down for 3 seconds and travel 12, or for 4 seconds and travel 12, or for 5 seconds and travel 10, or for 2 seconds and travel 10. There's no way to get 9. You'd have to hold it for in between 2 and 3 seconds, or in between 4 and 5. But we can still imagine our opponents are playing that way, and that will tell us how long you would have to hold the button to get their time, and then we just need to find how many ints there are between that amount and the winning amount, or the best theoretical amount. So we can say here's how their race would have played out if they had held the button for this impossible number of milliseconds. Their distance is their speed, which is s, multiplied by k minus s, which is how long they had remaining to travel that speed. We can simplify by distributing the s. Distance is sk minus s squared. Set the equation equal to 0. That's how you solve things. I don't know. When you find... We have tools for finding out when an equation or a formula yields 0. And so set things up that way. So subtract the sk and the negative s squared from... I guess that's not quite how I did it. I subtracted d from both sides and then rearranged the right side. So we get negative s squared plus sk minus d is 0. Now there's 3 variables here, so it doesn't look like, a typical one variable equation. But of course, k and d are both constants that were given to us. We're only trying to solve for s. So in general, the general case, yes, there are 3 variables. But any specific case we're trying to solve, k and d are given, so we only have to solve for s. So we can use the quadratic formula here. A is -1. We have -1s squared. B is k. Actually, it would be better to say ks, wouldn't it? So it's more clear. And c is -d. So I've written those here. And you plug in the old fancy quadratic formula, which is -b plus or minus the square root of b squared minus 4ac, all divided by something weird, minus 2a, or no, 2a, yes. And I did make a mistake here where it took me a while. I had written plus here instead of minus because I forgot one of the minuses in the -1 times minus d. So I was just getting impossible answers. But you do this and you get like... We can choose plus or minus here. Either one is a solution. And only one of them will yield a time less than k. So I just chose minus. Obviously, if you wrote k plus something... It'd be like, I don't know. I think they both work out. Maybe? Doesn't matter. So, where are we? I worked through the one example they gave us. A 7-second race, distance 9. 7 minus the square root of 13 over 2, which is about 1.7. And the best distance you could have is 3.5. And I did some thinking about how do you figure out how many ints are between 3.7 and 3.5 and 1.7. But then I looked at the end of the problem statement and saw something that made me think about it a little bit more clearly. You could hold the button for... Now they're talking about the second race here, but the way they phrased it for the first race wasn't as clear to me. The button for at least 4 and at most 11 milliseconds. And so I realized, oh, right. Instead of like figuring out how many there are between their worst and their score and the best, and then doubling it, but sometimes adding and subtracting one depending on whether the race duration is even, what I should do is just say, like, their score was achieved by holding down the button for some possibly fractional number of seconds, or could have been achieved in that way. And if you mirror that about the center of the region, i.e. k minus how long they took, that'll give you exactly the same score. And so that range is the range of winning scores. And I take a ceiling here because if you hold the button for less time than they do, you go even less far. If you hold it for ceiling, that's more than theirs. Although, actually, this is not quite right, is it? Because if theirs actually was an integer, right? Like if we end up finding that their distance or their time could be matched by going exactly 2 seconds, for example, then we can't beat them by going 2. We have to go more than 2. Right? So do I want like the floor of their thing plus 1 instead of the ceiling of their thing? Round it down and then add 1 to get to the next higher integer if you're not already at an integer. I think that makes sense. So something like that. 2 times floor of theirs plus 1. Then we'll add another plus 1 here. Because the number of ints between 2 ints inclusive is to subtract them and add 1. It's inclusive on both ends. So I think this is kind of the formula that I want, is to compute theirs as this, then compute the number of winning things as this. So that should be fairly straightforward to translate into Haskell, right? So let's go open up a source file. How do I make an Emacs buffer take up less space? Emacs buffer change. It's not really a buffer, it's a window that we're talking about, right? How to change the size of split screen Emacs windows? Control X caret? Is there a good way to do this with iDo mode? I have iDo everywhere. iDo max window height, okay, but iDo max window height. This is not that helpful. Well, maybe what I should do is just iDo window. No, those are different things. I don't want those. And now I'm stuck in the damn mini buffer. Okay, did I fix that? Good. So, Control X caret, huh? If it were iDo mode, if I could figure out the iDo function for this, I could do it interactively, but let's try shrinking it by 8. Can't enlarge selected window, huh? Fuck you! Why not? Okay. Well, I guess I'll just close this buffer and go visit it again later in a minute. I almost deleted the buffer, and then I would have to rederive all that stupid math. So let's... we want... I don't know. We could define types for time and distance, but I'm just going to use like ints and doubles, basically. Let's say... What am I naming this function? It's like number of ways to beat score? Actually, I think I do want types for time and distance. Millisecond millimeter, I guess. Because now we can have ways to beat record. Takes a millisecond and a millimeter and returns an int. Okay, I keep hitting tab to autocomplete, but of course it's alt slash and then tab indents, and I'm like mad about it. MSMM is let's see. K, which is the time, ms minus 2 times floor. We're going to have to convert this floor of theirs. Actually, hang on. What is the type of floor? Okay, it takes a fractional type and returns an integral type. That makes sense. Floor of record time plus 1, where record time is k, which in our context is ms, minus the from integral ms. Actually, you know what? Let's just write it down exactly as I have it here. K minus squirt of k squared minus 4d. I don't think technically I need the parentheses. I don't know. I always get confused about precedence between arithmetic operators. I spent too much time in Lisp and I don't remember how it works in real life. This is right though. We need it because otherwise it would be dividing by 2 the square root and then subtracting that from k, I think. Where k is from integral of milliseconds and d is from integral of millimeters. Does this type check? It does. But it is a fair point. Record time, I intended that to be a double. Does that make you feel any better? What are... Oh, you're asking what type this is and assuming it's integer. Sure, I mean... Let's just write k times k and then you don't have to worry about it. So, we could test this real quick with ways... Oh, I have to reload. Ways... Hello? Am I in the wrong directory? I'm in day 7 somehow? Wait, is today day 7? Hello? I can't type anything? What have I done? I quit GHCI somehow. It's day 6. Okay. Oh, that explains why I had some trouble starting up the thing, GHCID. I ran stack GHCI in this tab, then switched to the Emacs tab and started GHCID, and it was like, you haven't run Cabal, I don't know what your dependencies are. I was like, but I just started stack GHCI. It was in a different directory, it turns out. So ways to beat record of... Hello? It keeps like going into a hole where I'm typing keys and nothing's happening for a second or so. You know what? Let's go crazy here. Let's actually define these as real new types so I can't get them mixed up when calling this function. Already I tried to do it, see? So now, what are the ways to beat the record of... And what's given to us in the example is milliseconds 7, millimeters 9. There are 4 ways to beat the record. Is that correct? That is correct. How about 15 milliseconds and 40 millimeters? It says 8. That says that's correct as well. I'm just referring back to the problem statement off screen. Don't worry about it. And lastly, milliseconds 30 for 200 millimeters. So there are 9 ways to win. And that's what the problem agrees we should get for all of these. So, great. We have tested, I mean, not super thoroughly, but we have tested our closed form solution here. And now we just have to write a parser, which should be very simple, and then call part 1 to get the answer for this. I guess I could take a little digression for anyone new to Haskell here to explain why I thought changing from type to new type was going to help us avoid confusion. If you write, type, as we've done in previous examples, it's just another name for the same type to save you some typing so that you can write something shorter. In this case, well, not just so you can write something shorter, it also makes the type signatures use the name that you gave. You can say this, if I said, and this would be perfectly fine, I could say type, okay, yeah, now it's not because I wrote this, but I could have done, and indeed did do briefly, this. Oh, this. And that's perfectly fine. If I ask what is the type of ways to beat record, it says, millisecond to millimeter to int. But suppose I had gotten confused and wrote, I forgot what order it takes the parameters, and I wrote 230. Well, I didn't reload. It would say there's 199 ways to beat the record. Because in order to not go at least 30 millimeters in 200 seconds, you basically have to not push the button at all. That's the only way to not beat the record. And if I didn't really contextualize this, I might say, yeah, that's sure, 199 seems fair. Because these are just different names for the same type. Any int is a valid argument there. So I can just, at the call site, make a mistake and pass the ints in the wrong order. By putting things in new types, like so, I can still make this mistake, but at least I have to, like if I say, oh yeah, 200 millimeters, 30 seconds, it'll say, no, that doesn't type check. You made a mistake, right? You gave me milliseconds where I thought you'd give me millimeters, and millimeters where I thought you'd give me milliseconds. So in order to make this mistake, I would have to write, 200 milliseconds, 30 millimeters, and now it'll give me the bogus answer. But at least I didn't just put things in the wrong order. I also had to label them wrong to make this mistake. And it sort of becomes clearer, even wait a minute, this type or these arguments don't really make a lot of sense, right? And that might trigger you to be more suspicious. Anyway, 200 millimeters, 30 milliseconds. Oh, whatever. I don't know. Oh, it was the other way around. Okay. So there you go. That's why I think a new type is warranted here, because you could very easily get those two ints confused. Whereas in day 5, I just wanted a shorter name for a specific kind of map. Anyway, so let's write a little parser. What do I even need? What is the... Okay, you know what I'll do? Let's get my input for day 6, please. That's the whole input? I could do this by hand. Why did I bother writing out a form, converting the formula to Haskell? I should have just, okay, sure. I wonder what part 2 will be. We'll see. Okay, well, sure. It's going to be a list of times and a list of distances, but we'll want to convert that to a list of paired times and distances, I guess. We need string, we need... Do I need anything else? I guess I need some... I imagine that's re-exported by this, right? Yeah. So I've been importing this from control.applicative, which is technically where sum lives. But textregexapplicative re-exports it as a parser combinator, which has the same type. I guess this would just save me some hassle. Let's do it this way. I think I want sim for like it's a space. And that's probably it. And I want decimals, as I usually do. I think that's all I need for the parser. And I don't know what other imports I could need, really. This will probably be just like a function for part 1, honestly, but let's leave it here for now. Type. Well, say data record, I guess. There's a record of milliseconds and millimeters. Why not? Oops, lowercase deriving, please. I don't know if I'm going to need eq or ord or anything for these. You wouldn't think so, right? Maybe part 2 will demand it, but part 1 doesn't. I think our input is going to be a list of record, but we'll get to that later. Type parser of A is an RE_char of A. A professional Haskell programmer would at some point figure out how to use text instead of string, but for advent of code, it's like never necessary. The size of the files is just not large enough that it matters. So I guess they're separated. Okay, so I mean, I almost feel like I should just write the parser for the entire input, and like I don't need any smaller combinators, right? So let's go ahead and do that, I guess. Put the input up here. It's a list of record. We will not be type checking for a while. That's okay. Input is a parser for inputs. Input is zip with record of, which one's first? Times? Yeah. Times distances, where times is what am I doing about the new lines? I guess times and distances can each just end with a new line? Sure. Times is a row of time. You know what? Let's just inline this. And row is a row of label is string label, and then a sim colon, and then some number of copies of some sim space followed by a decimal. Hang on. Decimals are going to give me int, of course, whereas I want milliseconds and millimeters. Let's just do this here. No, I don't know. It's suddenly getting a little long. Let's just... row of millisecond time. I guess it would be a little clearer the other way. Time milliseconds and distance millimeter. And we'll just apply F in here. And all of that is followed by a new line. Right? I think that's it. Illegal term level use. Oh, I called these MS and MM. And yeah, it's complaining that our prepare is wrong, which we knew. So prepare is maybe, I mean, we should really use from right here. Maybe error no parse of from maybe error no parse of composed with equal tilde input. Yeah, I need to import from maybe, of course. Import data maybe from maybe. Variable not in scope. Oh, I forgot to import that. Equal tilde, you madman. Good. Okay, so that parses, or it type checks even. So let's read file input.txt to prepare. No, not that. We don't want to bind prepare, we want to fmap prepare. There you go. So there's our records. 40 milliseconds, 215 millimeters, and so on. And there are 4 of them, which is what we expected, right? Yeah. 40, 215, looks beautiful. Okay, great. So, part 1. What am I supposed to compute for part 1? Number of ways you could beat the record in each race, multiply them together. So part 1 is product dot... Oh, ways to beat record could actually take a record now that I have this type, couldn't it? Like so. Product dot map ways to beat record, turning an int. There you go. Seems pretty cool. Let's stack run and see what happens. That's a number. It's not prime, I can tell you that, so it must be a product of some numbers. Okay, let's give it a try. It's the right answer. Oh, sorry, I didn't let you guys see me fill it in. Here you go. It's the right answer. So, great. Let's... There's some stuff. I don't know what program it is that keeps writing dis new style. I think it must be GHCID is doing this sometimes. Get that shit out of here. And get rid of the sample input as well. Basics part 1. Nothing special to say about this. Nothing that like needs to be broken up or whatever. Yeah, and the input is just a parser for input. I mean, honestly, I guess I'm only using the parser type once. I guess I could just not use it. There you go. Now no one but you and me will ever have to know that I ever named that type. All right, on to C part 2. The race is about to start. You realize the piece of paper with race times and record distances you got earlier was just very bad kerning. There's really only one race. Ignore the spaces between the numbers on each line. Oh, okay. Easy. So this example from before actually means this. Sure. So it's a good thing we have a closed form solution. It's actually like converting these numbers that's going to be the hard part. I could just write a different parser, but I don't think I should do that. I could have done this whole thing without writing a program today, apparently. Just do a little bit of algebra and then like do it by hand. I would use a calculator though. So I still need a computer's help, I guess. Like a wimp. Soft, fleshy human who can't do, 18-digit arithmetic in his head. Or whatever it is. Actually, how big is our input? 15 digits? I mean, that certainly fits within an inch, right? Yeah. It does not fit within a 32-bit int, which is a little surprising to me that they would make you do this. But okay. Actually, hang on. Aren't I squaring one of these numbers? I'm not squaring the distance, though, right? I'm squaring the time. What's our time? It's an 8-digit number. 16 digits. That still fits within a 32-bit int. Right? I mean, I guess we could, to be super, super sure, we could check. 409, whatever. But, yes, that's much, much smaller than necessary. But, of course, I said I was squaring it. And the fact that it ends with 5, 10, how many zeros? 10? Eight zeros, which is twice as many as there were here, tells me no weird overflow has occurred. It still is visible by the same number of 5s as it was before. So, yeah, that should be fine. So what we need, I guess, is a... What do you would call... I guess we could call the function kern, right? This is annoying. I have to now unzip everything that I just zipped together. Ways to beat record of real record. We'll just call record here, where record is a record of ms of kern times and of kern distances. Yeah, I guess I can just... The times is map we'll give these record accessors, I guess. Get ms of records. Distances is map get mm. Oh, this still doesn't work, does it? Because the record needs, okay. Time and distance. I'm probably shadowing those now somewhere already, right? No? Yeah, so this is an int, and it'll say we don't have kern in scope, but I don't think there's any other problems, right? Get mm. Oh, did I get did I get all these names wrong? Okay, hang on. Get time, get distance, get ms, get mm. So this one's capitalized. I got you there. Oh, I didn't call these get. Okay, time and distance then. Yeah, now it's just upset I haven't written kern yet, which is fair enough. Kern of digits, numbers, components. Kern of, it's so stupid. How do you multiply? How do you run together digits? I absolutely will not turn them all into strings and multiply and then call read. Will I? Maybe I will. That's so easy. Okay, fine. Is read of read composed with I guess just bind show? Yeah, why not? That is a lot easier than doing math, isn't it? So we're going to call show on each of them and then concat the results. That's what bind does. And then we read the result of that. So, I mean, what do you think? Does it blend? It's a number. That's the right answer. Okay, nice and easy. I think we probably could scrounge up 2 different commits out of this. Right? Where the first one is giving accessors to the new types and the data, and then the other one is part 2. How come I didn't end up so input made sense to parse without using those accessors, obviously. We're not accessing, we're just building. Ways to beat record, just pattern matched, which makes sense. And part 1 doesn't mention them. Okay, cool. Sure, I will do this in 2 parts. Day 6, add new type accessors. Actually, they're field accessors, right? Day 6, part 2. Nice and easy. Oh, I do the pushes off camera. A quiet, simple one. Hope you guys enjoyed. Thanks for watching, and I'll see you next time.